Copper alloy and injection molding. The statement highlighted in yellow is not true, and I do not recommend that you use it for your injection mold design and construction. When used in steel molds, copper alloy cools hot spots, reduces or eliminates the need for cooling channels by minimizing the temperature differences of mold parts. Copper alloy provide tighter molded tolerances and less post-mold shrinking or warping. Remember that hot gets hotter if not properly connected to a cooling system. These are the effects of heat on metal. Subjecting metal to extreme heat causes it to expand in addition to impacting its structure, electrical resistance, and magnetism. Thermal expansion is pretty self-explanatory. Metals expand when subjected to specific temperatures, which vary depending on the metal. The actual structure of metal also changes with heat. Referred to as allotropic phase transformation, heat typically makes metals softer, weaker, and more ductile. Number 1. Strength. Mold materials, copper alloy, must be strong enough to withstand molding stresses, high molding temperatures, filled and acidic plastic resin. This include glass and metal fillings. All mold components in the cavities and cores made of copper alloy must be connected to a cooling system. Number 2. Corrosion of copper must be addressed because copper is susceptible to oxidization in elevated temperature environments. Corrosion of copper at elevated temperature is a serious problem for precision molding. Common mistakes made with copper: sharp internal radii, poor venting, corrosion, insufficient cooling, improper welding, the wrong coating, improper machining techniques. Sharp internal corners. Avoid sharp internal corners where tensile stress is concentrated. Poor venting. Poor venting can lead to damage from dieseling. Picture number 1 shows a no-good mold design, unplated copper core without proper venting. Picture number 2 shows a good mold design, properly vented core with plating to limit corrosion, overheating and galvanics. Overheating copper causes severe corrosion. Galvanic results from corrosion of steel in contact with copper. Poor cooling design. Copper moves heat, it doesn't eliminate it, so make sure insert gets cooled. Cooling lines can be heat bottleneck. Create turbulent flow. Prevent scaling, and biofouling slides often are not sufficiently cooled. Use hoses. Make firm contact with cooling plate. Improper welding. Use of the same alloy for filler. Keep it clean. Failure to heat treatment post-weld. Large and thick welds. Machining recommendations. Use sufficient horsepower while milling. Use positive polarity and copper electrode during EDM. Flush debris during EDM. Copper alloys, when used properly, reduce cycle time, improve part quality, extend tool life.